Welcome back to the classroom. My name is Mr. Wong. Today we'll be going through another exam paper question. This is the 1996 HSC Physics paper, question 32. This is to answer Module 5, Inquiry Question 3. This is going to be all about motion in gravitational fields. So we have the following table containing information about the planet Uranus and the dwarf planet Pluto, discovered after Kepler died. You have these values here, in years and also in kilometers here. It says, show that the information above is consistent with Kepler's third law, the law of periods. So the idea is very simple. Okay, so according to Kepler's law, if two different planets are orbiting around a star, okay, then their ratios of their radius orbit cube over t squared should be equal. So for Uranus and for Pluto, you should find that they're all equal to each other at the end of things. Okay, so that's what we're going to try and do to prove this scenario here. What you could do is convert these units, so to get that into seconds and to get this into meters. So times 10 to the power 3. So this, instead of 9, would be 12. 12 here. And then in terms of years, times 360, you have 24 hours in a day, times by 60, times by 60 seconds. Okay, so that's how we're going to do our conversions. Okay, so we want to show that both sides are equal to each other. So I'll do the one for Uranus. So 84 years times 360, 24, 60 times 60 cube over, well, that's our orbital period. Whoops, wrote it the wrong way around. So our average distance is 2.87 times 12 to the power of 3, because that's what we have there. Then we have our period. And then we'll just rub this bit up here out. Then we'll do a Pluto. So you'll have these values as we go here. Okay, and now it's time to calculate. So I'll do my answers in a different color. So we get approximately, I'll do it in 3 sig figs, 3.37 times 10 to the power 18 as our ratio. And over here, if we round it off to 3 sig figs, very close, just off by the second decimal. So 18 there, sorry. So there's that. Okay, so values are consistent. Obviously, the only difference could be just the rounding off difference. If we didn't round off, probably be a bit more close together. So values are consistent with Kepler's third law. Next one. If the mass of the dwarf planet Pluto is this value here and its radius is this, determine the acceleration due to gravity on the surface of Pluto. Okay, so if you recall, gravitational force can be written in two forms. This one here and this one here. Okay, we want to find little g here, so we'll equate this equation together. We don't need the smaller mass. Okay, that's irrelevant. So little g equals to big G over m over r. So big G is our constant times our mass of Pluto over our radius. Okay, just making sure that it is r squared. It is r squared. So 2.3 times 10 to the power 6 square. Okay, put that in the calculator. Okay, so the answer that I get rounded to 3 sig figs is 1.164 meters per second square. Okay, and last bit is explain the significance of the word universal in Newton's law of universal gravitation. So universal just means that gravitational force applies to all objects with a mass. And that's how you do the question. If you found it useful, give it a like, subscribe if you haven't done so already, and I'll see you next time.